Hello students, myself Rakesh Kumar Pandey. I am going to discuss very important topic, that is Kirchhoff's law of electrical network. It is very important topic for your JEE and your NEET exams. So we have to understand that Kirchhoff's given two laws to solve different types of electrical circuits. The first Kirchhoff's law is Kirchhoff's first law or Kirchhoff current law or junction law. It is based on the conservation of charge, because according to the Kirchhoff's first law, in any electrical circuit, suppose that this is an electrical circuit, the total current coming at a junction, that is total incoming current at a given junction, is equal to the total outgoing current at a given junction. This is a point P. This point P is called junction. So what is Kirchhoff's law? In any electrical circuit, the total current at a junction is equal to 0, because in any electrical network the total incoming current is equal to total outgoing current. We can say that sigma I equal to 1 to n equal to 0. And you have to understand that what is a junction in any electrical network. Junction is a point when two or more than two wires meeting at a point. This point in this given figure, this point P is called junction. P is called junction. So in a junction, in the given diagram, P is a junction where some currents are incoming currents and some currents are outgoing current. We have to take positive sign for incoming current, and negative sign for outgoing current. So you can see that from the given circuit that what are the incoming current here. I1 is incoming current, and second I3 is incoming current, and I4 is incoming current. We have to use positive sign for incoming current here. I1, I3 and I4 are incoming current, and we have to take negative sign for outgoing current. Therefore minus I2 minus I2 minus I5 minus I6 equal to 0. So you can see that the total current coming at a junction is equal to 0. This Kirchhoff's first law is based on the law of conservation of charge. It is based on law of conservation of charge. So you have to remember that first Kirchhoff law is based on conservation of charge. Let us discuss this question related to the Kirchhoff's first law. From the given circuit, you can see that 17 ampere current is coming at junction B. So we have to solve these problems. We have to find the unknown values of current in the given circuit. After that, this 17 ampere current is divided into different forms. Some currents are incoming current and some currents are outgoing current. From the given circuit here, B, C and D are three junctions. First junction is B, second junction is C and third junction is D. and we have to apply first law to solve the unknown values of current. If we talk about the first junction at junction at junction at junction B, at junction B, incoming current what is? Here is I1 is incoming current and what is I2 is outgoing current. Therefore, I1 minus I2 and also I3 is outgoing current. Therefore, I3 equal to 0. So, what is the value of I1? 17 minus what is the value of I2? 3 minus I3 equals to 0. Therefore, it is 14 minus I3 equal to 0 implies I3 equal to 14 ampere. So the our first unknown value, that is I3, its value is 14 ampere. Now we have to discuss at junction C. At junction C we have to solve another value at junction C. So here I3 is incoming current plus I4 is incoming current and I5 is outgoing current. So therefore I3 plus I4 minus I5 equal to 0. So what is the value of I3? It is 14. What is the value of I4? It is 2 minus I5 equals to 0. Therefore I5 equals to I5 equal to 16 ampere. It is the value of I5. I5 equal to 16 ampere. Now we have to solve at junction D. Solve at junction D. Here I5 minus I6 minus I7 equals to 0. What is the value of I5? It is 16 minus I6 and what is the value of I7? It is 9 equal to 0. Therefore 7 minus I6 equal to 0. Therefore I6 equal to 7 ampere. So we have calculated all unknown values. I3 equal to 14 ampere, I5 equal to 16 ampere and I6 equal to 7 ampere. So this is very important law. Now we have to understand about the Kirchhoff's second law. Kirchhoff's second law is also called Kirchhoff voltage law. And we have to first of all write the statement of Kirchhoff's second law. According to Kirchhoff's second law, the algebraic sum of potential difference that is product of current and resistance. The algebraic sum of potential difference and EMFs in any closed loop is 0. What is closed loop? This is a closed loop. This in the given circuit there are two closed loops, the first loop and the second loop. We can also take this A, B, C, D, F, G, A is also a big loop. So in any electrical network, the algebraic sum of potential difference, that is product of current and resistance and EMFs in any closed loop is 0. That is sigma IR plus sigma E equals to 0. And it is based on the law of conservation of charge. It is based on the law law of conservation of charge. Law of conservation of charge. So we have to implement Kirchhoff's second law in the given circuit. We have to understand the directions because we have to take directions for writing the equations of this circuit. So we have to follow that some rules. Suppose that this is a resistance R and current flowing in this direction, and we are also moving in this direction. We are also moving in this direction. Our motion. Then we have to take the sign minus IR. You have to remember this basic fundamental. If we are moving in the circuit in this direction, current flowing in this direction, and this is resistance, then we have to take minus IR. If just opposite, suppose that it is R and current moving in this direction, but our motion is just opposite. Our motion हम जैसे ऐसे मूव करेंगे ना, मूविंग इन अपोजिट डायरेक्शन, देन वी हैव टू टेक इट्स साइन पॉजिटिव प्लस IR. Okay, now in case of potential difference, if this is the sign, current flowing in this direction and our motion is in this direction. We are moving in circuit in this direction. Then we have to suppose that this is E. Then we have to take sign minus to plus. That is, we have to take its sign plus E. And suppose if it is positive negative and current flowing in this direction, and we are moving opposite in its direction. Our motion, we are moving in the circuit in its direction from positive to negative, then we have to take its sign negative. These are the four fundamental rules we have to use while writing the equation of the given circuit. Let me explain it again. Suppose current is moving in this direction and we are also moving in the circuit in this direction. Both are in the same direction, then we have to take minus IR. And in second case, current moving in this direction and we are moving opposite to the direction of current, then we have to take plus IR. And in third case, this is the source of EMF. Current is in this direction and our motion is in the same direction. Then this is negative and this is positive. Then we have to take EMF positive. In the fourth case, current is in this direction and we are moving just opposite to the direction of current. Then we have to take EMF here negative. So we have to use this fundamental rule to write the equation of the given circuit. So let us start writing the equation of the given circuit. We have to discuss in loop A B F G A. We have to move in this loop A B F G A. So we have to first of all move A to B. If we are moving A to B, then current in this direction and we are moving in this direction. So we have to take from the first loop, that is minus I1 R1. In this case, from B to F, we are moving in downward direction and current is also going in this downward direction. So we have to take minus I3 R5. From F to G, we are moving in this direction and current is also in this direction. So we have to take minus I1 R3. Now from G to A, current is in this direction and we are moving from negative terminal to positive terminal. So we have to take it positive. So E equal to 0. Therefore E equals to I1 R1 plus I3 R5 plus I1 R3. This is our first equation to solve the electric network, and now we have to discuss in second loop. In loop B, in loop B, F, D, C, B. B, F, D, C, B. So, if we are moving from D to F, so in this case current and our motion both are in same direction. So we have to take minus I3 R5 from F to B. We are moving in the same direction as current moving. Therefore, it become minus R4 I2. And from D to C, here we are moving in the same direction of current. It is minus and it is plus. So we have to take sign here. Here we have to put E1. Here this is E1 and this is E2. Student, we have to write here E2. Okay. So minus plus E2, and from C to B, it is we are moving in the same direction as the direction of current. So we have to take here minus I2 R2 is equals to 0. Therefore, E2 equal to I3 R5 plus I2 R4 plus I2 R2. This is our second question. So in this way we have to solve any electrical network. This is the basic calculation to solving the electrical network, but now we have to understand this by solving a question. Now students, I am going to solve the JEE and PYQ question. It is very interesting question related to Kirchhoff's law. We have to find voltage drop across 12 ohm of resistance. So in this given circuit, let me explain what is the given circuit. In this given circuit, the E1 is 7 volt. The internal resistance of EMF E1 equal to 1 ohm, and suppose I1 current is flowing through it. In the second source of EMF E2, its value is 13 volt and its internal resistance is 2 ohm. And there is another resistance 12 ohm. It is connected with parallel to both the sources of EMF E1 and E2. So we have to solve this circuit using Kirchhoff's law. Okay. So let us start. We have to discuss the equation for the loop A, E, F, B, A. We have to move in this loop. A, E, F, B, A. So starting from A to E, there is no resistance. So after E to F, current flowing in the circuit is I1 plus I2. So it become, because we are moving in the direction of current, we are moving E to F, moving in the direction of current. So it become minus I1 plus I2 into 12. Now from F to B, there is no any circuit element. From B to A, what is the current? That is I1 current, and what is the internal resistance? That is 1 ohm. So we have to take here minus I1 into 1. Now the source of EMF, we are moving from negative to positive. So it become plus E1. So we have to take plus 7 equal to 0. Therefore minus 12 I1 minus 12 I2 minus I1 plus 7 equals to 0. Therefore minus 13 I1 minus 12 I2 plus 7 equals to 0. Therefore 13 I1 plus 12 I2 equal to 7. This is our first equation. 13 I1 plus 12 I2 equal to 7. This is our first equation. Now we have to solve again in the second loop, in loop C, E, F, D, C. C, E, F, D, C. So from C to E there is no any element. From E to F. From E to F it is minus I1 plus I2 into 12. Because we are moving in the same direction of current, so it becomes minus I1 plus I2 into 12. Now from F to D there is no element. From D to C. From D to C 2 ohm internal resistance and I2 current flow in this circuit. Therefore it is minus 2 into I2, and we are moving from negative to positive terminal and value is 13 volts. So plus 13 equals to 0. Therefore minus I1 minus 12 I1 minus 12 I2 minus 2 I2 plus 13 equals to 0. Therefore minus 12 I1 minus 14 I2 equal to minus 13. Therefore 12 I1 plus 14 I2 equal to 13. It is our second equation. So we have to solve these two equations. Now we have to solve by the method of elimination method. You already studied in 10th class how to solve these linear equations. So we have to multiply first equation by 12 minus second equation by 13. So 12 into 13 it is 156 I1 plus what is 12 into 12 144 I2 and 12 7 84 and we have to multiply 13 by second equation. It is 156 I1 plus 14 into 13. So we have 4 3 are 12 and 4 3 7 1 8. It is 182 I2 equal to 13 into 13 equal to 169. So we have to solve this value, minus cancel out. So we have to subtract this value. What is it? 12 minus 4. 12 minus 4 it is 8. Okay. So it is 12 minus 4 8 is 7 minus 4 38. It is minus 38 I2 equal to its value is, what is it? It is 5 and it is 8, that is minus 85. So what is the value of I2? I2 equal to minus 85 upon minus 38. So I2 is approximately 38 to the 2.25. It may be approximately value 2.25 or it's 2.25 ampere. I am taking its approximate value, it is become 2.25. Now we have to take the value of, calculate the value of I1 from equation, from first. What is 13 I1 plus 12 I2 equal to 7. Therefore 13 I1 plus 12 into what is 2.25 equal to 7. Therefore 13 I1. I have taken its approximate value, student. So it is not exact, it is about the value. So we have to multiply it by 12 by 5 into. So it has become 24 and 24 and 24 27. 1 over 4. It is about 27. So 7. Therefore 13 I1 equal to 7 minus 27. 13 I1 equal to, it is approximately 20. Therefore I1 equal to minus 20 upon 13. Therefore I1 equal to, what is its value? Approximately 13 1 13. It is 7. It is approximately 1.6 ampere. Approximately, we have to take some extra value. It is approximately 1.6 ampere. So we have calculated the both values I1 and I2. Then we have to calculate the effective value of current. That is I. I is equal to I1 plus I2. Okay. Therefore minus 1.6 plus 2.25. So we have to subtract it. 2.25 1.60. That it is 5. It is 12. That is 6. It is 1 minus 1. That is, it is 0.65 ampere. 0.65 ampere. So we have to calculate the voltage drop across 4 ohm resistors. So what is the voltage drop across V12 ohm? It is I into R. What is the value of I? 0.65. And what is the value of R? It is 12. So we have to multiply it. 12 5 ja 60, 0 carry 6, 12 6 ja 72. 72 and 6. It is 78. So its value becomes 7.8 volt. Okay. The value is 7.8 volt. V12. It is our resultant value of the given. So voltage drop across 12 ohm is 7.8 volt. Thank you, students.